This is 4.3 Right Triangle Trig Day 3, Introduction to Identities. Identities are very important in trigonometry. They are the rules by which we play, and we've already covered many of these identities. We've done SOHCAHTOA, we've done the reciprocal identities, and we've talked a little bit about a quotient identity. So we're going to look at a few other types, and then we're going to begin to use them. This is the introduction. We're going to cover this in much more depth later on in Chapter 5, but I'd like for you to begin to see how these things fit together. Okay, here's an example on proving the Pythagorean identities. Pythagorean theorem, of course, we know. Here's the example. We have the cosine of theta is 3/5. We have the sine of theta is 4/5. And then I also have written over here some terminology, some notation. When you see cosine written this way, it means cosine written this way. And so when you square cosine, the notation is to write it like this, but this is what it means. Okay, so for instance, what we're going to do here is we are going to square cosine, and then we're going to add it to the square of sine and see what we get. All right, so we don't really know what theta is, but we know what its ratio is. So I'm going to rewrite this as the cosine of theta quantity squared plus the quantity or sine squared. And then since we know that cosine theta is equal to 3/5, that means I can substitute 3/5 for the cosine theta. Now 3/5 is a ratio, it is not theta. So I'm not substituting it for the theta, I'm substituting it for that whole thing, the cosine of theta. And I'm going to do the same thing over here with sine theta and square it. So I have 9 over 25 plus 16 over 25, which is 25 over 25, and that equals 1. So what I've shown is that the cosine squared, try that again, the cosine squared theta plus sine squared theta is equal to 1. Another interesting thing is that you can actually, this is an actual quantity, sine squared, so I can subtract it to the other side. And this is also an identity. Or vice versa, I can say sine squared theta is equal to 1 minus cosine squared theta. So from this one identity, I can form two others. And so that's how this kind of goes. It's like a little formula that you're going to be together. Now, what was the point of all of this here? The point of all of this here was to prove that cosine squared theta plus sine squared theta is 1. It's equal to 1. And so this is going to be an identity. Just this one you need to memorize because you can derive the others from this. And once again, it's going to be one of those things where we're going to use it so often, it's going to become second nature. Okay, so here's a summary of the identities that we know so far. And these are the main ones, and so these are the ones that you need to remember. But SOHCAHTOA, when you have sine theta is opposite over hypotenuse, and cosine theta is adjacent over hypotenuse, and the tangent of theta is hypotenuse, my goodness, what's up with that? Opposite over adjacent. All right, and then we know the reciprocal functions. We know that sine theta is equal to 1 over cosecant theta, and which of course also means, or leads to 1, cosecant theta is 1 over sine theta. All right, and so I'm just going to write them one way but you know that you can get them the other. So cosine is 1 over secant, or secant is 1 over cosine. And then you have tangent theta is 1 over cotangent theta. The quotient identities, we learned this very early on. We know that the tangent is equal to sine over cosine. But we could also say that the cotangent of theta is cosine theta over sine theta. So those are our quotient identities. And when I say identity, that means there's an equal sign between them. So if we found these in a problem, we could substitute one side of the equal sign for the other. The Pythagorean identities, there's actually 3 of these. The first one you're going to use more often. And you can start it with either one, but I better start it with cosine. So I have cosine squared theta plus sine squared theta is equal to 1. And then there are actually 2 others. And they start out with secant squared theta is equal to 1 plus tangent squared theta. And then cosecant squared theta is equal to 1 plus cotangent squared theta. And if you look at these, you can start to see some patterns. I will tell you that we mostly use these 2, the first 2, and the last one we use sometimes. I would say we most definitely use this one, this top one, and then this one sometimes. This one more often than we use this one. We use the reciprocals all the time and SOHCAHTOA all the time. So these are ones that you're going to need to write down and memorize. These are the rules that we have for identities. Once again, memorize them. The goal of working with identities is to use the trig identities to transform one side of an equation into the other and assume that all angles are in quadrant 1. You're going to want to write these down, these rules, in your composition notebook. Rule 1, generally you work with the more complicated side to make it look like the other side. And I know it cut off one letter on this end over here. You're going to work with one side only. You never move anything across an equal sign. You're going to keep the sides separate. You're making one side look like the other. And that's number 4. Okay, here are a couple of examples of some problems that you would say, and these are going to ask you to prove the identity. Okay, so we want to make one side look like the other. So we want this side, this looks like the more complicated side, to end up looking like 1. And what we're going to do is we're going to use our identities to replace things here to simplify. So for instance, I know that secant is 1 over cosine, right? It's a reciprocal function. So if I have secant theta is equal to 1 over cosine, that is the identity. Okay? So since there's an equal sign between them, I can replace the secant with the 1 over cosine. So rewriting, I have cosine theta, that's the cosine theta that we brought down, times 1 over cosine theta, right? And so this is over 1, that's over 1. They cancel, and I have 1 equals 1, and that proves the identity. That whole thing is the problem. Okay, so starting with this one over here, this one looks like the more complicated side. Notice I'm not going to move anything across the equal sign, but I am going to replace or substitute each of these. Hopefully I will get to this side. Well, I know I will, but okay, here we go. So first of all, I'm going to write the identity. So I know that tangent is sine, using the quotient identity, over cosine theta. I can write that. And then cosecant is 1 over sine theta. So do I see anything that cancels? Well, of course I do. So I'm going to cancel. These are a form of 1. Sine over sine is 1, and I end up with 1 over cosine theta. Well, I'm really close, because remember that 1 over cosine theta is the reciprocal function of secant theta. And so I can say that secant theta is equal to secant theta, and I'm done. All right, so this is just an introduction to proving these identities. Okay, one more example, and this one is actually done for you in your book, but I want to walk through the steps with you so that you can kind of see where we're headed on some of these. When you look at this problem, you can notice that this sort of looks like the difference of two squares. Right? So just regular algebra looks like a plus b, a minus b, right? That's what it kind of looks like. I don't know what's up with the a there. Okay. All right, so when you multiply that out, that's a squared minus b squared, right? This is what we would use in algebra to do this. Well, you can actually treat trig functions the same way. So what that means is that I could actually multiply this out as if it were the difference of two squares. Okay, so that's what we're going to do. So I'm going to do secant times secant is secant squared. Secant times that is negative secant theta tangent theta. When I multiply these together, I get plus, and I'm going to reorder them so I can see that they're going to cancel. And then the last then would be minus tangent squared theta. So you see that these two terms right here, plus and minus, it'd be like adding one, subtracting one, they'll be 0. And I'll be left with secant squared theta minus tangent squared theta. Now that's not beyond you, but it certainly is not 1. But we're getting closer. So we did have a Pythagorean identity, and let me change colors here because I want you to see secant squared theta was equal to 1 plus tangent squared theta. Okay? And so that would mean that where there is a secant squared theta, I could replace it with 1 plus tangent squared theta. And so that's what I want to do here. I want to, instead of write secant squared theta, I want to write 1 plus tangent squared theta, and then bring this down, minus tangent squared theta. And I'm getting closer because this quantity, tangent squared theta minus tangent squared theta, is 0. So I'm left with 1. And if I bring this 1 down, that's what I wanted it to look like. I wanted it to look like the other side, and I have 1 equals 1. All right? So this one's a little more complicated than the ones you're probably going to do in class, but I want you to see that it's all related. All the algebra and everything you've been learning, we're going to use in our trig class. So be sure that you copy down all the examples. Be sure that you take the notes and write question marks next to anything that you would like to go over again. And I'll see you in class.